My name is Evan Burton, and this summer I decided to build a DIY CNC Plasma Cutting Table. It was a tool that I had needed, but I didn't have the money for, so I decided to make it as cheap as I could. Lots of research and design went into this project. I based a lot of the design on these linear guide rails I was able to find on Amazon. And some stepper motors that I already had and ended up sizing up. For the CAD model, the cross rails are for the x-axis, which just moves the whole machine back and forth. You can see there's some pockets for the stepper motors to go, and they eventually run belts all the way the length of the x-axis. The y-axis does the same thing, it just moves across the center, and the z-axis is just that block on the front, which I was never intending on making the Z myself. It was going to be cheaper just to buy one online than to try and make it myself. I used these pulleys for the motion on the whole X and Y, and then the Z axis ended up being this one that I found on Amazon. I ordered all of the steel I used for the frame of this project from a company called Warrenton Steel. It took a few weeks for it to get there, but that helped me finish planning, and then once it got here I started my manufacturing process. All the steel is MIG welded, and all of the holes were drilled with a drill press that I built last summer. Now, about this time was the first tests I was ever able to do. Just the x-axis moving. The electronic setup is obviously very, very temporary, and it was just on the floor in the living room of my basement, but it was a good proof of concept, and it helped me make sure that my idea was actually going to work before I put more money into it. It was at this point in the project I figured out a really awesome tool on Fusion 360, which is the the drawing function, where I can take sketches and be able to print them out so I could mark and drill accurately. This was awesome. I wish I had had this earlier, but better late than never, and it helped me make this plate. This was 3/16 steel welded together. It mounted to the y-axis, and it was what the z-axis mounts to. It's a really important connector piece. High-speed accuracy test. Pretty good. After I was sure that the y and x-axis were going to work together, I decided it would be time to get limit switches in place, which would allow me to use hard limits and soft limits for this table. The software I'm using to run the whole thing is called Grbl, GRBL. It's open source online, and it's made for homemade CNC machines. They have a lot of stuff available for plasma cutters, so it was incredibly helpful. I found these limit switches online and was able to make some 3D printed clamps so that I could mount them all where I needed them to be. The homing sequence worked. First beta tests of all 3 axes. It looks like a schizophrenic wired it because it's 1 in the morning and I am so tired. But we'll go ahead and run it. So it'll start with the z-axis first. It's hard to see it moving. The search speed is very low because I was really worried it was going to hit something. This was the first time I was able to run a program on it. I'm using Grbl on an Arduino to run the motors, but I need a G-code sender, so I'm using Open Builds Control for this project, and this was before I had the probing in place, so the Z-axis is stationary. We'll draw a big circle. And sets it back to 0.
That's crazy.
Attached to the Z-axis is something called a floating head switch. As a sheet metal you're cutting warps under the heat, you need to have the torch do a probing sequence so it can feel where the metal is. Realized that I didn't need to reinvent the wheel, and I found this really cool one on Thingsverse by this dude. And then I put it on my machine and did a test with the probing. Now it was time to get the electronics in a more permanent place, so I found this electrical box that would act like a Faraday cage because the electromagnetic interference from the plasma cutter is really high. So I also had to use this shielded wire for the input switches and the motors and the trigger switch. All of it has to be shielded to avoid messing up the controller. And then I had to learn a lot about grounding and the importance of it not acting like an antenna. And all in all, it helped a lot. I don't know if it 100% solved the issue, but it definitely helped. At this point, the table was still like a glorified 3D printer. It had no cutting ability and it didn't have legs yet, so it was time to give it a proper stand, get the electrical box mounted, make some shelves to put the plasma cutter on and my laptop on when I run it, just to really start finalizing everything. And this was probably the last time for a while, hopefully, that I'll have to assemble and disassemble the machine. Now, this is also the part in the project where integration hell begins. It had already kind of happened, but everything was just going wrong now. I figured out that the plasma cutter is a 24-volt circuit that is normally open for the trigger. So I modified the box to have a 4-core or 4-module relay now. That's just running the output switch, and then the 5 volts is set to the trigger switch. So when I select the tool on, you can see that it clicks on and off. So tool control is done. I ate those words the following day. Did not. The torch control was not done, and it did not work to drive the torch. Turning the machine. Oh, that scared me. Actually almost needed to change my pants. Some glimmer of hope told me to just run the program and see what would happen too. If you notice from earlier, the red light means that it's on. So it's constantly sending a high signal, which means I should have had it normally closed, and I wired it normally open, which is why the switch was on, the exact opposite it was supposed to be. Turns out the arc was also going out because the cutter didn't have enough watts, and the only outlet in my whole house with enough watts was our dryer outlet in the laundry room. So I ended up running a 75-foot extension cord out the window and down the side of my house. And I also bought the wrong adapter for that outlet twice. But third time's the charm, and it did end up working. Just stand closer, bro.
Dog.
Guys, it worked. You still videoing?
Yes.
Good. Okay. Now bring it over. I need to knock it out. It's probably still really hot. Come over. Come over, you.
Holy crap.
Bang. The accuracy being within 1/10 of a millimeter is pure luck, and gave me enough hope to try and cut something much bigger, which was the logo for the place that I trained jiu-jitsu. And I think it went on for 4 hours straight. This was the design I was actually supposed to be cutting. Sizing it up and stuff was really easy and getting it on the table, but the cutter would not do two sequential cuts in a row, and I think it was because of the EMI. And the only way for me to fix that would have been to adjust the shielding, and I was not about to do that. Uh-oh. Let's stop. I did end up just shutting hard limits and soft limits off because it is still triggering a hard limit for some reason, but it's saying it was as an earlier event. I don't know why it's halting it. The torch actually isn't even active when it happens, so something's wrong and I'll figure it out eventually, but for now, those limits are off and probing is off just so that I can get it to cut what I wanted, and it's also still a relatively small cut, so the probing is not completely necessary for this. The last little bit of this video is just going to be it running the full big cut and then the final result. So ready to resume. Overall, was really fun to build. I enjoyed it a lot, and now I get to use it for a whole lot more future projects. The final cut that this just did honestly came out a lot better than I thought it would, which just makes me happy because this is actually going to be a useful tool for me in the future. If you'd like to build this yourself, a lot of the stuff I got on Amazon for pretty cheap. Leave a comment and I can definitely help you.